Good morning, chemistry students. My name is Mr. Adam. This is chemistry. Today is the 9th of April. It is a Thursday, and it is a day 1. So happy Thursday, everybody. We're almost through another week of online learning. I hope you're doing well with this new way of learning. I hope you are managing to get the assignments done in all of your classes and not having too much trouble with all that. I've been getting more and more emails and more questions from all of you. Less about the content and more just worrying about scores and worrying about points and everything like that. And again, I'm going to stress this pretty much every day, but please remember, don't overstress. If you complete a Google form and your score is a 4 out of 14 or a 5 out of 14 or a 6 out of 14, don't worry. One, those Google forms aren't perfect at grading, so generally I take a look at all the answers and make sure, if it wasn't a multiple choice question, that what you put was close enough to the answer that I was looking for. I will be grading those, I will be looking at them, seeing how many points you got, but again, we're on a pass-fail system now. Don't worry too much about it. As long as you're getting a reasonable amount of the material, and as long as you're putting forth your best effort on these, you should be okay. Do not worry too much. That being said, I will look at these. I will try to give you feedback when I can. It's going to be difficult to give feedback to everybody, but that's what the answer key really is there for. Once you complete your quiz, your assignment, check out the answer key. See what you got right, see what you got wrong. If you put 2 unpaired electrons and 2 lone pairs, but you put them in the opposite order and the quiz told you it was wrong, but you got it right, take that as feedback that you know what you're doing. You know what's going on there. So like I said, don't overstress on those. I do manually grade them when I need to. Just make sure you're doing your work, getting it turned in, getting it done, and we should be okay. That being said, email me if you have any questions. Let me know if you're ever worried about anything. Okay. So yesterday, we talked a good bit about these things called Lewis dot structures. And these Lewis dot structures, or Lewis structures, show how atoms are arranged and connected to each other. And we said we can figure out how atoms connect to each other by seeing how many valence electrons they have and seeing how they would bond to fill up each other's octets. We used this word octet yesterday for the first time because, well, it was in our steps for drawing Lewis structures. But we haven't really formally talked about what the Octet Rule is yet. Well, today, you're going to be figuring that out. You're going to be reading the chapter in the lesson called Octet Rule. And in Miss Marnick's video, I don't want to steal too much of her thunder today, but in Miss Marnick's video, she does a great job of explaining what the octet is and what the Octet Rule is, and in showing you how to draw things that have complete octets. Like I said, I don't want to steal too much of her thunder, but I do feel odd if I'm not teaching you anything and letting her do all of it, so we'll go through a little bit of stuff about the octet. Okay, so octet is our word for today. Octet, like octopus or octogenarian, which is an 80-year-old plus person, means 8, right? So an octopus has 8 legs, an octet has 8 electrons. An octagon has 8 sides, right? So the Octet Rule doesn't mean that everything starts with 8 electrons or starts with 8 valence electrons. It means that everything wants to get to 8 valence electrons, right? It wants to get there as quickly as it can or as easily as it can. And it can do that in different ways. If it's making an ionic compound, remember that, it's been a long time. If you have a metal and a nonmetal bonding, an ionic compound will form, and that means that it'll give away or take electrons to get to 8. Remember we said it would form a positive or a negative ion to try to get to 8 electrons. We played the game Who Wants to Be a Positive Ion and saw who would gain and who would lose electrons. Now that's not the case for molecules. For molecules, they're going to share electrons. And when they share electrons, they form a covalent bond. Now if they share a pair of electrons, that's a covalent bond. That's called a single bond. And that's just sharing 2 electrons, right? You just shake hands and you share 2 electrons and that's a single bond, right? For a thing called a double bond, they're going to share 2 pairs of electrons. How many would 2 pairs be? That'd be 4 electrons, right? So they're sharing 4 unpaired electrons to form a double bond and kind of a double handshake, right? And you can even see these things called triple bonds where they share 3 pairs of electrons. And those 3 pairs of electrons would be 6 total electrons. Now all of those have to be unpaired on that atom to start, so it has to want to form 3 bonds in the first place. But then if it does, it can share 3 pairs of electrons to form a triple bond. So every atom in the world follows the Octet Rule, where it wants to get to 8 valence electrons. Remember, it can't be more than 8. It can be anywhere from 0 to 8 that it starts with, but it can't go more than 8. This is true for everything except hydrogen and helium, but helium doesn't really bond with anything because it's a noble gas. Okay, this is true for everything except hydrogen. Hydrogen only ever wants 2 electrons. It's perfectly happy with 2. It starts with 1, okay? So it's only going to form 1 bond. It only forms 1 bond because it needs to get to 2. It only needs to get 1 more, share 1 more, to get to 2 valence electrons, okay? So hydrogen is the exception, but everything else in the world wants to get to 8. We're going to do some examples here. Let me go grab my periodic table right over here. We're going to do some examples today with 3 different molecules. And Miss Marnick does a ton more examples, but we're going to do a couple just to show you all 3 different kinds of bonds, okay? So here we have 3 different molecules. They are F2, O2, and N2. These kinds of molecules are all what you call diatomic. They each have 2 atoms, and those atoms are the same. So this is what we call diatomic fluorine. This is diatomic oxygen. And this is diatomic nitrogen. Diatomic meaning 2 atoms, like diameter. I'm trying to think what else di comes from. Okay. But di means 2. Dissect means to cut in 2, right? Okay. So we have F2, O2, and N2. I've started drawing the Lewis structures for each of these, but I haven't put in the electrons yet. So our first step when drawing any of these, again, is to figure out our number of valence electrons. When we look at nonmetals, you're going to figure out they're usually in the upper right-hand corner of the periodic table up here. So let's look at F first, right? So F has 7 valence electrons. O is going to have 6. N is going to have 5. So let's start with F, okay? So let's draw out our valence or our Lewis dot structures for each F here. Okay. So we're going to do north, east, south, west. Okay, so that's 4, north, 5, east, 6, south, 7. All right, so there's 7 electrons in this Lewis dot structure. And so if you were telling me what this Lewis dot symbol looked like, you would say it has 3 lone pairs, because this pair is by itself on a side, this pair is by itself on a side, this pair is by itself on a side, and 1 unpaired electron. And that unpaired electron is the only one that's going to be able to form a bond. Lone pairs are good. They're perfectly happy by themselves, and they don't really want to move or bond with anybody. But unpaired electrons are sad and lonely, so they're going to want to form bonds. Okay. So we have F2 now, right? We have 3 lone pairs on each fluorine, and we have 1 unpaired electron. What did I say about those unpaired electrons? They want to form a bond, right? So fluorine is going to want to form 1 bond because it has 1 unpaired electron on each one. So this should be easy, right? You're going to take your unpaired electrons and connect them together and pretend that circle only goes around those unpaired electrons, right? So you're going to take your unpaired electrons and put them together. So when you do this final Lewis structure, what it's going to look like is this. So it's going to have 1 pair in the middle, just like that. What you can actually do is you can write that 1 pair of electrons in the middle as a single bond, which is just a single line. So that's one way of writing that Lewis structure. I'll leave that up for a little bit longer, okay? So those are a couple different ways of writing those Lewis structures. There is a single bond because you've only put 1 pair of electrons in between those fluorines. So that's called a single bond. But we're going to see what happens when we have more than 1 pair that we end up sharing. All right. Second one, we have O2, right? We just looked at the periodic table. O was in column 6, or 16, or 6A, whatever you want to call it. O was in column 6, so it's going to have 6 valence electrons. So have a sheet of paper out, be doing this with me, right? Okay. We're going to put 6 valence electrons around oxygen. So 1, 2, 3, 4, 5, 6. Okay, so again, 2 lone pairs and 2 unpaired electrons. Same deal for this oxygen. We're going to start in the north. 1, 2, 3, 4, 5, 6. Okay, so each oxygen has 2 lone pairs, 2 pairs by themselves that aren't going to do anything. They're just going to stay there. And 2 unpaired electrons that want to form bonds. Now, O2 means that you have two oxygens. You can't have any more oxygens than that, and they have the electrons that they start with. So how are those going to bond together? Well, you could say, and they're just going to do the exact same thing that fluorine did, Mr. Adam. You're going to have this electron here, pair up with this electron there. Perfect. One bond, right? You put a pair in the middle and you're good to go. But you still have two unpaired electrons on each of these oxygens, right? You still have these two. So what are they going to do? They're going to form a bond, right? So these are going to form a bond as well. Okay. So you can have atoms forming multiple bonds with each other. And if it forms one bond, it's called a single bond. If it forms two bonds, it's called a what? It's called a double bond, right? So we're going to draw the structure for that O2 with those electrons in the middle, with it sharing two pairs of electrons. Okay? So it's going to look just like this. Okay? So why would it do this? Why would oxygen want to share two pairs of electrons? Well, one, we know, thanks to honk 1, 2, 3, 4, that oxygen has to form two bonds. And two, remember that both of these atoms, even though they start with 6 valence electrons, want to get to 8. Everything wants to get to 8. Everything wants to get to 8. Everything wants a full octet. So let's see, for each oxygen here, does it have access to 8 electrons? We're going to circle this one in blue. Okay. So for this oxygen, it has access to both of these lone pairs. And it has access, we say, to every electron in that bond, in that double bond. So it has access to these two, 1, 2, 3, 4, and all 4 electrons in this bond, 1, 2, 3, 4. So that is a total of 8. What about this oxygen? We check it out. Has access to these two lone pairs, 1, 2, 3, 4, 5, 6, 7, 8, 4 in the bond. So both of those are happy because they have access to 8 electrons. Even though they only started with 6, even though they both needed 2 more, what they can do is just share even more with each other to get to that 8, that perfect happy 8 octet. All right, last one. We're going to actually erase O2 so we can see it for this. All right, last one. We got nitrogen, right? Nitrogen, if you look at your periodic table, is in group 5A, column 5. So it's going to have 5 valence electrons. So let's draw out the Lewis dot symbol for nitrogen. 1, 2, 3, 4, 5. Okay? So on that nitrogen, you have 1 lone pair and 3 unpaired electrons. Those 3 unpaired electrons really want to form bonds. Okay? Nitrogen over here. I'm in the way. 1, 2, 3, 4, 5. Right? Okay. So same deal with that. Same deal with that nitrogen. It has 1 lone pair, 3 unpaired electrons. It wants to form 3 bonds. Okay, you only have 2 atoms. They both want to form 3 bonds and get to 8 electrons. So if they both want to form 3 bonds, why don't we just give them 3 bonds, right? Why don't we bond this pair here, and then this pair here, right? So why don't we just bond all 3 of those unpaired electrons together? If we have 1, 2, 3 bonds, what kind of bond is that? We have a single bond, double bond, and a triple bond. All right, so a triple bond is a little bit more rare than a single or a double bond, but it does happen with atoms like nitrogen that only start with 5 electrons that like to form 3 bonds. Think about honk 1, 2, 3, 4, right? Honk 1, 2, 3, 4 says that nitrogen should form exactly 3 bonds. So if you just have nitrogens, they're going to form exactly 3 bonds. Right here. This is what we call a triple bond. And again, I'm going to write it out in lines because I like to write lines for my bonds. Right? So this is N2. It forms a triple bond in the middle. Let's make sure it follows my octet rule, right? So this nitrogen, it has access to all three pairs of electrons in the middle, all 6 electrons in the middle, and those 2. So it has 1, 2, 3, 4, 5, 6, 7, 8, right? Even though it started with 5, it shared 3 pairs, which is really nice of it, and it got up to 8 electrons. This nitrogen, which one? Okay, this nitrogen here, same deal, has access to these, 1, 2, 3, 4, 5, 6, 7, 8. Has access to 8 electrons, full happy octet, right? So, this gets a little bit more complicated when you start working with more than 2 atoms, right? When you start doing things like C2H2, C2H4, C2H6. Miss Marnick is going to walk you through all of that, so make sure to watch her video today. I know with my video and her video, it's a little bit much. Like I said, I always watch them at like 1.5 times speed to make them go a little bit quicker, but you watch them however long you need them to get this stuff down. It's important that you learn this still, even though we are not in school. It's still important that you keep learning. Do whatever you need to do that. You can watch multiple videos, you can watch other resources, you can do the reading, but make sure you're doing enough so that you get this stuff. And when you're doing the assignment, definitely check in on the reading and on the notes, because there are a lot of answers in there. Okay, with all that being said, that's kind of our lesson and our content for the day on the Octet Rule. Hope you guys are doing well and hanging in there during this time. Like I said, we're almost through our 2nd week of online learning, so it's good stuff. For the share of the day today, what was I thinking for it? I can't remember. I can't remember what the share of the day was. So, for that, I'm actually just going to keep it open-ended. Share something with me. Share something about your life right now, what's going on, what you miss, what's been good, what's been bad. But just share something with me today. If you send me an email, if you send me a question, just give me a holler and let me know what's going on in your life. Because as always, I care about you. I care about the chemistry you learn. I care about what you actually learn and what you know, but I care more about you and what's going on in your life. So share something with me. No specific share of the day today. With that being said, I will see you all tomorrow for our Friday. Have a great day. Work hard, stay positive, and stay calm. All right, I'll see you all tomorrow. Let's get a 1, 2, 3. Clap on me.